Let us discuss this example. In this example, we have a set U and we have to prove that it is an open subset of R2 with Euclidean distance. Okay. See, what is meaning of this set 2x plus 3y? Normally, when we have inequality, first of all, we have to consider equality there. Then we will come to know the graph and then we will talk about the proof. Okay. So, 2x plus 3y is equal to 1. It's a line actually. It's a line, and less than 1, that means some part, that means this line divide the plane in two parts. So out of this two we have to consider one part. Okay, so this is the actual geometry behind it. Okay, but see, we know the method. Simply we will follow the method and we can easily prove it. Okay, what is our method? What is our method to prove a set is open? We take any arbitrary point. After that, we draw an open ball around it, and then we prove that open ball entirely lies inside a set. In this way, we prove that set is open. Let us start to do. Here also, I am going to take one arbitrary point of view. Let P is equal to P1 comma P2 belongs to U be any arbitrary point. Okay, this is a arbitrary point. So this is point in U, so obviously it will satisfy the condition. So therefore 2p1 plus 3p2 less than 1. We have to select radius which is positive. Okay, so my focus is on positive real number. For that, I am going to shift this term on that side. Implies 0 less than 1 minus 2p1 minus 3p2. Okay, these were positive. If you shifted on that side, there will be negative numbers. I am going to divide both sides by 5. What will happen? So this is 0 less than 0 upon 5 0. 1 minus 2p1 minus 3p2 divided by 5. See, I am calling it as R. We want radius, no? So I am taking it as radius. Let R is equal to what we have got here, 1 minus 2p1 minus 3p2 divided by 5, which is greater than 0, since already we have proved here it is greater than 0. So now my claim is if you draw open ball around P with radius R, it is subset of U. Getting now what I am going to prove? Open ball with center P and with radius this R is subset of U, and if we can prove it, we can declare U is an open set. How to prove one set is subset of other? We take one arbitrary point of first set and we prove that that is in second set. So that's why we can declare first set is subset of second. So let us take one point from it. Let x is equal to x1 comma x2 belongs to that open ball with center P radius R. This point lies in ball, that means distance of point from center is less than radius. So that's why distance of x from P is less than R. Distance, which is a Euclidean distance here, since we have R2 with Euclidean metric. So therefore this is norm x minus P less than R. Tell me what is our x? X is x1 comma x2. What is our P? P1 comma P2 less than R. How to subtract? Obviously component wise. So therefore x1 minus P1 and x2 minus P2 less than R. Do you know how to find norm? Yes, obviously definition is square root of first plus square of second, but there is no more space, so I suggest you to make a screenshot of it. Let us find its norm. Okay, how to find norm? Square root of first plus square of second, okay, less than R. To remove square root, I will take square of both sides. So therefore x1 minus p1 square plus x2 minus p2 square less than r square, sorry. sum of these two non-negative numbers is less than r square. That means each of them should be less than r square. So that's why x1 minus p1 square less than r square and x2 minus p2 square, that is also less than r square. Okay, so I will take square root of both sides. What will happen? Positive square root. So that's why mod will be there. Okay, and this side also. You know the property of mod a less than b if and only minus b less than a less than b. So that property I am going to use. So therefore here we will have minus r less than x1 minus p1 less than r, and what can I write here? Minus r less than x2 minus p2 less than r. Okay. See, this part is not required. We are interested in only this part of inequality. So therefore x1 minus p1 less than r, simply I am writing, and x2 minus p2 less than r. Let me remove it, it is not required now. Okay, so let us continue. So see, what will I do? I will shift p1 on that side. So x1 less than p1 plus r and x2 less than p2 plus r. See what I am trying to do now, I am trying to bring that inequality here. Okay, so my focus is on that inequality. So for that purpose, I need to multiply both sides by 2. So it will be 2x1 less than 2p1 plus 2r, and here I have to multiply by 3. So therefore 3x1 less than 3p2 plus 3r. After that we have to add. Let us add now. So this is 2x1 plus, here 3x2 I supposed to write. 3x2 less than, if you add 2p1 plus 3p2 plus 2r plus 3r, 5r. You remember the value of r? R was 2p1 minus 3p2, like that, getting a 1 minus 2p1 minus 3p2 upon 5. So therefore 5r will be, I will put the value of 5r, 2x1 plus 3x2 less than, I will write in bracket, because value of r is 1 minus 2p1 minus 3p2 divided by 5. This is a value of r. So that value of r I am going to put 2p1 plus 3p2. If you put value of r here, 5 is there as a multiple of r. 5 will get cancelled. So therefore 1 minus 2p1 minus 3p2. So implies 2x1 plus 3x2 less than 2p1 minus 2p1 will get cancelled to each other. 3p2 minus 3p2 will get cancelled to each other. That means we will have only 1. So therefore this point satisfies this condition. So therefore x1 comma x2 is member of U. So actually we had taken that point from open ball and we proved that it is member of U. So that's why open ball is a subset of U. I'm going to write it. Just before that, make a screenshot of it. Therefore, we had taken x point from ball and we proved that x belongs to U. Get it? So therefore, this open ball is subset of U. And P was any arbitrary point. So that means for each point of U, we can find some radius such that that open ball will entirely lies inside U. So therefore we can declare, therefore U is an open set in R2. Yeah, in this way we finish the example. Okay. So make a screenshot of it. After that we will stop. Thank you. Bye bye.